Welcome to Graphs of Sine and Cosine, and along with this lesson we're going to do some exact values of sine, cosine, and tangent and fill in the table that you learned so that we can use this as we're doing graphing and with other things that we do in Trig. So we're going to basically do a lot of graphing with sine and cosine. We're going to again talk about amplitude, frequency, period, and midline, and we're going to add on to that horizontal shift and phase shift, but that will be a different video. We are going to look for formulas for the periodic functions using sine and cosine. So I don't really ask you to find tangent graphs at all, but we will talk about the tangent function. Whoops, excuse me. Okay, so let's fill in the exact values. Now on the last video I actually showed you where these come from, and we're only going to do quadrant 1, and we're going to do this pattern that you need to see. So this is a pattern, and as you learn this you'll have to have this memorized, so please write this down. You have to memorize this. I actually will want you also to memorize 180 and 270, so we can add that on the bottom here to help you. Alright, the first thing we're going to do is put, these are the angles in degrees. I want to put them in radians, so it's 0, and since pi is 180, it's pi over 6, pi over 4, pi over 3, pi over 2, 180 is pi, and 270 is 3 pi over 2. Yes, I expect you to know that and to be able to convert. Now, sine are my y's, cosine are my x's, tangent is y divided by x, like slope. Here are the 4 quadrants, so we can always look at this for the 4 quadrants, so we can fill that in at first. So if we did the sine, so here's my first point, 1, 0, so since the point is backwards, it's going to be 0 and 1. And so sine starts at midline, cosine starts high, and we will be talking about that with the graphing, but that's basically kind of where it comes from. When we go all the way down to 90, which is this point here, that's cosine sine, so this is sine cosine. Sine goes all the way up to 1. Cosine starts at 1 and goes to 0. Okay? So this is going up and this is going down. So let's look at the pattern as it goes up. So the sine of 30 is radical 1 over 2, or 1/2, radical 2 over 2, and radical 3 over 2. And we learned those before, and then it goes all the way up to 1, which is radical 4 over 2. Cosine starts at 1 and goes to 0, and it goes backwards because it's counting down. So this is radical 3 over 2, radical 2 over 2, 1/2, and 0. Okay? Now let's put the point in for 180. So here 180, it's negative 1, 0, so it's going to be the sine is 0, the cosine is negative 1, and 270, it's 0, negative 1, so it's negative 1, 0. So we've got the quadrants in. Now tangent is y divided by x, so 0 divided by 1 is 0. Let's skip down to this one. Radical 2 divided by radical 2, radical 2 over 2 divided by radical 2 over 2 is 1. 1 divided by 0 is undefined. We'll just write UND, but it's undefined because you can't divide by 0. 0 divided by negative 1 is 0, and negative 1 divided by 0 is also undefined. Now I didn't put 360 here because 360 would be, of course, the same as 0. So the other two you have to kind of memorize is tangent of 30 and tangent of 60. So if I did 1/2, just to show you the algebra, divided by radical 3 over 2, and I look at this and say, oh, they have 2, if I multiply the top and bottom by 2, they'll cancel out. I'd get 1 over radical 3, which I have to rationalize, and when I do, I get radical 3 over 3. So that's the tangent of 30. The tangent of 60 is radical 3 over 2 divided by 1/2. And again, I multiply the top and bottom by 2 to get rid of it. That's radical 3 over 1, or radical 3. So this table you need to memorize. I don't know how much I need to tell you that, but it makes life a lot easier. Okay? So next slide, it says find the exact values. So I don't want you to memorize that table and then not know what it's for. Okay? So what you're going to do basically to find exact values, and this is a part of a quiz I will be giving you, is first of all, you'll have to go through and mark where this is. So here again, this is divided by 3. I know this is 0, so this is pi, but since it's got a denominator of 3, we're going to call it 3 pi over 3, and then this is 6 pi over 3. Okay? And now 2 pi over 3 is in the second quadrant. Now, you have to look at it and say, well, 2 pi over 3 is not in my table, but I know my reference angle is pi over 3, and sine is positive, so this is the same as saying the sine of pi over 3, and it's positive because sine is positive in that quadrant, which comes out to be, the exact value of that is radical 3 over 2. Cosine is 7 pi over 6, again, 6 pi over 6, 12 pi over 6. I'm using the denominator of 6. So 7 pi over 6 would be in this quadrant. My reference angle here is pi over 6, but cosine is negative, so it's the same as saying the negative cosine of pi over 6. Now, if this is confusing to you, you need to come and see me, because basically all I'm doing is finding reference angles, but instead of degrees, I'm doing it in radians. Now, negative cosine of pi over 6 is like saying the negative cosine of 30, which is going to be negative radical 3 over 2. The sine of 5 pi over 4, well, let's look where that is. This is 4 pi over 4, 8 pi over 4. So 5 pi over 4 comes in this quadrant. So I'm pi over 4 away. That's my reference angle. Sine is negative in that quadrant, so it's minus the sine of pi over 4. And I know that's 45 if you want to, so it's negative radical 2 over 2. Now, if you want to stop this video and practice and try the bottom 3 by yourself, by all means, please stop it and then see if you know how to do this, because I'm going to expect you to know how to do this. All right, 11 pi over 6. First of all, I got to find out where it is. So this is 6 pi over 6. 12 pi over 6. 11 pi over 6 would be way over here in the 4th quadrant, because I'm almost up to 12. I'm pi over 6 away. Sine is negative in that quadrant, so it's negative sine of pi over 6. And the negative sine of 30, if you will, is going to be negative 1/2. Tangent of 5 pi over 3. 3 pi over 3. 6 pi over 3. 5 pi over 3 is way over here. I'm pi over 3 away. Tangent is negative in that quadrant. Pi over 3 is the same thing as saying 60. So it's negative radical 3. 9 pi over 4. Let's draw it, see where it ends up. This is 4 pi over 4. 8 pi over 4. Now this one's a little different because 9 pi over 4 goes all the way around and ends back up in quadrant 1, which is still pi over 4. And tangent's positive in quadrant 1, so it's going to be the tangent of pi over 4, which we know as 1. Now I quickly kind of went through that. So there's a couple things I want to make sure that you know in this finding the exact value. Is I want you to draw the picture, label it, find out where it is. Converting back and forth to degrees is a waste of time. If you get practicing this and understand what radians are, this is a much quicker method. All right, this next slide I took from the internet, and it has every single value. If you'll remember, I noticed that I showed you to memorize quadrant 1. So quadrant 1 you need to memorize. And then we did each quadrant here. So we learned this, 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 and this, and then I had you memorize quadrant 1. Because here, the other 3 quadrants we can use by using reference angles. Just remember the points here, everything's positive in quadrant 1. Here it's negative positive. Here it's negative negative. Here the points are positive negative. And remember, tangent is positive in these 2 quadrants like a line, and tangent is negative here and here like a slope of a line. Okay, now we're getting into actual graphing. And so I'm going to go through the properties of sine and cosine, and I want you to remember what I'm showing you. And first of all, there's this little saying I always say. I said sine starts at midline, cosine starts high. Because if sine starts at 0, we just saw that, and cosine starts at 1, sine will always start at your midline, go up and come down. So that's what that looks like. Cosine also starts high, comes down low, and looks like this. So this little saying helps you to determine what sine is and which one is cosine. The domain of both of these is all real numbers. Okay, I can put anything I want, and I'm going to get this periodic function, and it's going to repeat and repeat and repeat. The range for these is your y's are between -1 and 1. So the highest they go is 1, and the lowest they go is -1, and they're included, so it's from -1 to 1 in our interval notation. The midline for these functions is y equals 0, so it's right smack on my x-axis. And my amplitude is going to be 1, and remember amplitude is always positive. So those are the basics of the graph of sine and cosine. Amplitude, now we've talked a little bit about this. The one thing I want you to remember is amplitude is never, ever negative. Okay? So you just need to remember that. So a lot of times you will see amplitude in absolute value signs because it's never, ever negative. So it's the distance between the midline and the highest or the lowest point on the graph. And we usually graph from 0 to 2 pi, right? So let's look at these graphs here. I have y equals sine of t, y equals 2 sine of t, and y equals negative 0.5 sine of t. Well, I want you to recall what we learned in the transformation things, the chapter right before here. So let's first of all talk about how are they similar. Well, they're all sine curves. So every one of these are going to start at midline. Okay? Their midline is y equals 0, so they all start at midline. How do I know that? Because I didn't add or subtract anything after that. That's an outside change, so these will all be right at the x-axis. And all their periods are 2 pi because that's how long it takes me to see an entire curve. All right? How are they different? Well, I'm going to kind of put this up here. So how are they different? Well, this one has a 2 out front, so that means this has been stretched vertically by 2. And in the last chapter we multiplied 2 by our y's. So that's our amplitude, so it's going to stretch and it's going to be higher and lower. So it's going to go up to 2 and down to negative 2. This one, how is this one different, is not only is it multiplied by 0.5, but there's a negative there. So it's been reflected over the x-axis, or we call it inverted. So this one has been inverted. It's been reflected over the x-axis. And it's been compressed vertically because I multiplied it by a half. Compressed by a half, like somebody sat on it. So this one, if I were going to graph this, it's going to be half as high and flipped. Okay, so it's been inverted. Midline. This is a little review. Midline is when I add or subtract a constant after. So you're always going to say y equals k or y equals a number, and that is always going to be your midline. And I suggest that you always draw it to make sure. Okay? So if you look at this one right here, you'll see I have y equals cosine t here, and then I have cosine t plus 2. So this one actually has been shifted up 2, which makes your midline 2 because it's halfway between the upper and lower. So this graph is going to go up to 3 and down to 1 because it's been shifted up. Right? So the new midline is y equals 2 for that new graph. Okay? So again, to remind you, if you add or subtract either plus or minus, that shifts it up or down. It's a vertical shift. Okay? The other thing I want to show you about midline, so I'm going to give you this example, y equals 2 minus the sine t. Sometimes you'll see they'll put the midline up front. That's still, the midline is still y equals 2. But because this is negative, which means it's been inverted, they sometimes will throw, instead of having it start with a negative, they'll throw the midline up front. So I just want you to see this, just to note that this can happen. So you can rewrite it and put it at the end if you want. So you really could write this as y equals negative sine t plus 2. Okay, so you can rewrite it if you need to, but I just want to let you know sometimes they throw it up front. Now, we are going to practice this in class, but there are some graphing calculator tips that I want you to see. First of all, you have to make sure your mode is in radians, and we're going to practice this all in class because we have the TI Inspire calculators, and they do a nice job. You're going to graph your function and then zoom trig it. When you zoom trig it, your window is as follows. It goes, your y's go up to 4 and down to negative 4. Your x's go from 2 pi, or 6.28, to negative 2 pi. That is the standard window when you zoom trig. Okay? Now, not all our graphs are going to need that, but just so you know, the zoom trig does help, and we'll be practicing that in class. We're going to be checking your table set, and checking your window every single time. Unfortunately, the table set does not go with the window, so you're going to have to play with your table set to get the points that you need. Okay, so let's write down some calculator keystrokes. So you have to go to your home screen and put 5 in for settings to make sure that it's in radians. All right. Okay, let's practice a few of these to show you how we're going to do this. So we're going to graph 3 sine theta. Now I'm actually not going to show you the calculator part yet, but we will practice these in class. But I want you to do this. We're going to do this kind of by hand so you can see how it works first. First of all, I also want you to stack and rack amplitude, frequency, period, and midline. Okay? Because we're going to do this. And I look at this, there's nothing added or subtracted at the end, so my midline is y equals 0. It's really a plus 0 there. I come up, my amplitude, what's in front, is 3, so this has been stretched vertically 3. I look at what's in front of my variable is theta, and I see that it's a 1, so again, this is my equation. I can look at it and say, oh, my frequency is 1. Now my period is 2 pi over my frequency, or 2 pi over 1, or 2 pi. So that's nice that you have that all done so that when you go to graph this, you can see what you have. Now, I'm going to kind of put a little table here. So when we go to graph these, okay, if you know the period, because there's 4 quadrants, what we're going to do is we want to have, all right, there's 4 quadrants. We're always going to take our period and divide it by 4. So if I take my period, divide it by 4, I get pi over 2. And this is kind of what you count by. So we're going to start at 0, okay, and then we're going to count by pi over 2, 2 pi over 2, which is pi, 3 pi over 2, 4 pi over 2, or 2 pi, okay? Now, I have gone through and I've counted, so now I can do this. Now, when you go to graph this, it's going to be really cool because you got to remember sine starts at midline. So I know it's going to start right here, so it's going to be 0, 0. Now, at pi over 2, it comes up, comes down, so you get the how it looks. It looks kind of like an S, all right? So at pi over 2, it's going to go to its highest point. Well, in this case, since it's been stretched, it's going to go all the way up to 3. Comes back down to 0 at pi. At 3 pi over 2, it's going to go to negative 3. And at 2 pi, it goes over up to 0. So we're going to practice in class so you can get this set up, but you actually can graph this whole thing. So now, when I go to graph this, I'm going to try to do it nice, is swing an arc through this as best you can. I hope yours looks nicer than mine. And then if you have to graph it from negative 2 pi over, you can just repeat the pattern. Here, you don't need to show the table. Just repeat the pattern because you know it's periodic. And there, you've just graphed 3 sine theta. Okay? Let's do 2 plus 4 sine theta. Okay? Well, 2 plus 4 sine theta. This looks a little more complicated. And this is our midline right smack in the front. Remember I told you they do that sometimes? So, let's stack and rack amplitude, frequency, period, and midline. Put your equal signs there. Okay. Now I'm going to put the 2 over here just so I don't have to look at it. And I'll see that my amplitude is 4. My midline is y equals 2 because I just put it over there. My frequency is whatever's in front here, and it's a 1. My period is 2 pi over 1. My frequency, or 2 pi. Okay? Now, we take the period, divide it by 4, and this is what I'm going to count by, pi over 2. Now, the one thing I want you to know is because sine starts at midline, my midline is now right here. So I always kind of put this in. Here's y equals 2. So here's the center of my graph. So I know sine is going to start here. Okay? So let's do the table here. XY. Alright, so when I go to do this, again, I'm going to count 0, pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, or 2 pi. Okay, so now, alright, when I do this one right here, okay, I start at 0, 0. Now I know this one it's going to start at right here at 0, 2, because that's the center now. And then it's got an amplitude of 4, so it's going to go all the way up to 6, which is its high point right here. So this is a 6. We're going to come back down to 2. And then we've got drop 4 below, so it's going to come down to -2. Okay. Then it's going to go at 2 pi. It's going to go all the way back up to 2. So here is what this looks like. So it's been stretched and shifted up. Now, let's repeat this pattern. And if I'm going too fast at any time, please stop the video and go back, all right? I've done this a lot, so I tend to kind of move a little fast. Okay, the next one. We have -2 sine theta. Now on this one, I have sine theta, I get that. I have an amplitude of 2, but remember amplitude is never negative, so it's been stretched by 2, but then it's been inverted. So I have an inverted graph, or it's been reflected over the x-axis, and this is my amplitude. So I'm going to do amplitude, frequency, period, and midline. And the first thing I'm going to do is write it's been inverted or reflected over the x, because I don't want to make that mistake when I do this. The amplitude is still +2. My midline is still y = 0 because I'm not adding or subtracting anything at the end. My frequency is still 1, and my period is going to be 2 pi over 1, or 2 pi. If I take my period, divide it by 4, I'm still counting by pi over 2. So all that's the same. So I kind of like set my table up as I'm doing this. 0 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Okay. So I know my midline's right here, so I'm going to know, I know I start at 0, 0. Now, if it's been if it's been inverted, it's going to go down first. So it's going to go down to -2 first because it's been stretched. Come back up to 0, come up to 2, and then go back to 0. So it looks like it's reflected over the x-axis. That's why it's a negative sign. So if I repeat my pattern, it kind of looks like that. Well, congratulations, we just graphed a few without a graphing calculator, and we will practice this in class. Okay, we already know that a sine of t or a sine of cosine t is an amplitude in its absolute value. If a is negative, the graph is reflected across the x-axis. The midline is adding it, and the period is 2 pi over the frequency. So I just wanted you to have a slide that kind of summarizes everything we just did. Now, I'm going to spend a little bit of time going through this, and we're going to practice this in class, is basically describing what's going on here, and we're going to fill these all in. So I have this formula here, okay? First thing is, I know that this graph has been inverted because I have a negative sign. So I'm going to write inverted right here. I like my little sticky green dude guy there, okay? So the amplitude is a +1/2. Actually, I do not like these dashes. Nothing's negative here, okay? My midline is what's been added, it's been shifted up, is y = 7. Remember, the period is on your graph, so you have to figure this out. If you have an equation, you can do the frequency. What's in front of my variable is my frequency. That means I'm going to see 8 of those. My period is 2 pi over my frequency, or 2 pi over 8, or pi over 4. Now I want you to think about this. It's going to take me pi over 4 to see one of the curves because I'm going to see 8 of them in 2 pi. Okay, let's look at this one. This one has the 3 in front. So there's our midline. Remember, I told you sometimes I throw it out front. And then I have a negative sign, so it's also been inverted. So I want to make sure my midline, let's put some equal signs here again. I should not use dashes, is y = 3, okay? My amplitude is a +5, but it's been inverted. My frequency, which is in front of our variable t, which is 6 pi. Now remember what I told you before. If your frequency has pi in it, your period won't. So let's look at the formula. 2 pi over my frequency is 2 pi over 6 pi, or 1/3. And again, your period doesn't have it. All right? All right, let's write the equation for this graph here. And then we are going to finish. So I just want to end off with a bang here. This is how you're going to do when you write equations. You're first going to write looks like and put a line here. Then you're stack and rack amplitude, frequency, period, and midline, and then you're going to tell what the equation is. Okay? So I start right here. I always look at the y-axis and say, oh, sine starts at midline, cosine starts high. Sine starts at midline, cosine starts high. And I see that this starts at the midline because this looks like the middle of my graph. So let's figure out, this looks like a sine curve. So I'm going to say it looks like sine. Okay? Come down to the midline. We have to find the midline. So it's up here at 7. So that's my high. And you need to show me the work. High plus my low, which is 1, 2, 3, 4, 5, 6, 7. So it's negative 7 divided by 2. So that's going to be y equals 0. So here's my midline, so let's draw it. It's right here on the x-axis. Then I'm going to do my amplitude, which is high minus my midline, or 7. My frequency I can't tell from my graph, but my period I can. So I'm looking at it and say, okay, how long did it take me to see this? And right there it ends. So I count 1, 2, 3, 4, 5, 6, 7, 8. So my period is 8. Which equals 2 pi over my frequency. Flip their places, 2 pi over 8, or my frequency is pi over 4. So now I'm all set to do my formula. I can say y equals, amplitude goes first, 7, looks like sine, my frequency goes next, pi over 4x, and I could say plus 0, but I don't need to. Okay, well that completes how to write equations and a beginning look at exact values.